So, hello, this is Adrian. I'm on Linux here, and I'm using the tool Spider, and I'd like to draw your attention to a little trick that appears to be able, by this data here, to enhance the capabilities of neural networks a little. Now it's just a bit more of a tenth of a percent, but it's measurable. I've run this 30 times on my laptop computer, and so what we're dealing with here is so I've made this with Keras. I'm hoping to upload all this code in due time, and so the point is that so what we are doing here is this is basically, so I watched so the thing is I watched the video by 3 Blue 1 Brown, who is the famous online YouTube mathematician, and I mean, since the AI bubble is now bursting and AI is no longer cool, I have decided that I should enter the subject. And so I did, and so this was my idea, that I would improve these models using pure noise. I mean, what we're doing here is image recognition, and I've basically copied the model that 3 Blue 1 Brown used, and it has this shape, so the framework is Keras. This Keras notation for a neural network, which is probably the term I should use, because artificial intelligence as it is quite deficient at present. So what I did in this other file was that I appended data, and the model was to recognize that random data, which I had produced this here using an external function. This is just random noise data, which I created using the Python random function. And so this data is supposed to, the model is supposed to recognize this as rubbish data, and therefore, as we can see here, assign no specific number to it. And the idea is that random noise in the model would be filtered out a little. So basically, mathematically, so an ideal image recognition program would recognize noise as noise. And if mathematically we already have this ideal model, then what properties should it have? Well, it should assign this vector to random noise, and this is what has been tried to achieve by this program. And indeed, the results show, this is the upper line, this is the extended model, that it does appear to improve the accuracy by a little bit. I haven't tweaked the parameters. Perhaps with a larger model or different parameters, the effect would be even greater, but I really do not have the computational power, because unfortunately I happen to be a non-person. No, an unperson. Sorry. I confuse this, even though I am reading the book in English, as I want to emphasize. So that's a bit of a problem. But even on the small scale, I have been able to achieve some advantage. So as I said, I'm hoping to upload this on my repository, my code repository. And I would like to thank you very much for your attention, and I hope that perhaps this optimization can be used in the future to make image recognition more accurate.